Hello, everyone, and welcome to today's Tech Talk on Building Enclosure Commissioning Testing, Laboratories, Mockups, and In-Situ Field Testing. My name is Sherry Adams, and I'll be moderating for today's session along with Joyce Kelly. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use this control panel to submit questions. We'll be gathering your questions throughout the Tech Talk, and we'll have time for Q&A. If your question is related to a particular slide, please indicate the number of that slide in your question. A PDF of the slides from this presentation will be sent electronically to all those who have registered. We will also be recording this Tech Talk, and it will be available on our website under the resource section. Today's Tech Talk is brought to you by the Southwest Chapter of the BCA, and our moderator is Joyce Kelly, board member of the Southwest Chapter. Joyce, I'll turn this over to you.
Thank you, Sherry. I met Brian Melcher and his Field Verify team almost a decade ago. It was soon after I realized that building enclosure commissioning could make or break a LEED Platinum building in terms of energy performance and air quality. I've learned a lot from reading their exacting checklists and field reports and witnessing their testing, then turned their documentation into indisputable lead points for building enclosure enhanced commissioning. They've taught me to systematically photograph both details and their context for my field observations, and I can always get an answer on which building details to watch out for on every job we work on together. Whenever they test on-site construction or a mock-up, they carefully educate contractors, building owners, engineers, architects, and commissioning providers about what works and what doesn't. Now, Brian will educate us and illustrate the fundamental ASTM testing that helps protect our clients' investments.
Thanks, Joyce. Grateful for the opportunity to speak today. I love public speaking. This doesn't feel quite as much like public speaking. I'm realizing quickly how much I depend on audience feedback, but excited to be here today, and really in preparing today, had the goal of providing as close to an in-person experience as possible. So a lot of effort put into this presentation to be packed with video as much as we could. We're here today at our testing laboratory in Phoenix, Arizona, and captured quite a bit of video heading into this. And so we'll switch to really just a glimpse of what the laboratory setting looks like, just to set the tone for today. Here we perform building enclosure testing, laboratory mock-ups. We'll be talking today through the process of building enclosure testing, from laboratory mock-ups to in place or on building mock-ups, in the field or on building mock-ups, and the field testing that occurs for building enclosure commissioning. In 2018, Field Verified became an accredited field testing agency. It was a new designation, and we were the first in the country to achieve that. To be fair to all the laboratories that were accredited well before that, you don't need to be an accredited field testing agency unless you don't also have a laboratory, an accredited laboratory. So that was step one for us to become an accredited laboratory, testing laboratory in 2019. At the laboratory, we provide all of the fundamental test requirements and enhanced test requirements for laboratory testing. But really, to organize the presentation today, we're going to reference ASTM 2813, which provides guidance, really a list of mandatory and optional tests within that particular standard, but actually lists quite a comprehensive, as you can see, list of test options that are available. So with all those test options, whose responsibility is it to develop and determine which tests are appropriate? This guy. One of the core competencies of a building envelope, building enclosure commissioning agent would be to develop the scope of the mock-ups, of the field mock-ups, of the testing that occurs in the field. Because it can be a pretty complicated process, the core competencies listed for that really include having a knowledge of all of the different products in the testing. So before we start talking about building a mock-up and all of the pieces that go into a mock-up and onto a building, each one of those individual components is going to be tested. Air barriers are tested for air and water testing, adhesion, thermal performance, exposure, of course, fire testing. And so understanding the testing that goes into those products is really an important skill set of those that would be identifying the mock-up components and the testing related to that. We take it for granted sometimes that we get a particular air barrier and a whole sheet with product data and 17 tests and their ratings in the product data there, but it's the sum of those parts that are begun to put together, and all of that testing that creates that product data starts in a testing laboratory to define what each of those standards are. Within a laboratory, we've talked about the different types of products that can go through there, everything that's going to make up the exterior enclosure. Residential windows are a little more regulated. So when you've heard the term an AMA accredited laboratory, it's really getting down to the basics of the AMA accrediting of residential windows. In your home, probably tucked away in the corner of a window is a gold label sticker with a test standard and some ratings related to that. All residential windows are required to go through specific testing, and they receive a gold label and inspections during the testing and the fabrication process. That's what sets the standard for an AMA accredited laboratory. Storefronts and curtain walls will be tested similarly in a laboratory, determining the air and water ratings, thermal performance, sound transfer, and structural performance of the aluminum and the glass and the sum of all parts as a system. That's how we get to the 20 or 30 page submittal for a curtain wall that we see on a project. At some point, that system has been tested in a laboratory, and those results allow us to select that product for our project. You might see testing in a laboratory of a curtain wall system on your new project rather than selecting a profile that's been used before. A particular client may choose that they want a unique profile. Joyce and I have worked with University of Arizona that has some specific profiles they want to achieve for their aesthetic intent, and suddenly they're outside of a tested system. And so new laboratory test data would be required for that curtain wall system specific just to that project. And then of course you're going to have different criteria that you're looking to achieve as a manufacturer, depending on whether you want to sell that product in Florida, Canada, California, places with extremes. Certainly you're going to have to provide a higher performance rating to meet those locations requirements. So it's impossible really to talk about putting together a mock-up and putting together testing without talking about the design phase. The design phase is really meant to establish the guidelines for durability and performance of the project, and product selection is where that starts. So selecting products that meet each of the standards. Certainly from a mechanical standpoint, there will be requirements for the building enclosure that need to be provided to support that design. And as those products are selected, we may be looking closely at the performance characteristics, that test data that's been established already, But the designer's responsible to have an eye towards the compatibility, towards making sure those products match their performance standards, so you don't have select a very high rated curtain wall and then a wall system that doesn't match, because it becomes more of the sum of the parts for the building. And then of course how those connections come together and being able to maintain those ratings. We're not switching screens. That is the segue to mockups and mockup testing, because once we've selected those products and are ready to assemble them, it's the opportunity to bring it into a mockup and a testing situation to confirm that each of those work together the way that they should. So we'll start by talking about laboratory mockup testing. And this is really the first opportunity to focus on not just the performance characteristics of the individual products, but the constructability, how you're able to physically build out those details and fit the products together, lap the products together, an eye towards compatibility, and really begin to test the durability of those configurations. Then what we've achieved at this point now is a wall assembly rather than multiple components. So when building a mock-up, it's important to document the quality standards, document the install. Really similar to a mechanical system, there's a sequence of events that needs to be followed each time. We want to know what happened on the mock-up, because if we failed, we want to know why we failed. We want to know what the steps were that led to that. And hopefully when we pass, similarly, we need to know exactly what was done, the sequence it was done in, so that that can become the quality standard and the method of installation going forward. It might seem simple to say that, of course, you would want to document the installation process. It gets overlooked quite a bit, and it is really important when it's time to apply corrections, that you understand what you started with so you can begin to improve that and apply those lessons towards success on the building. That really is the goal of any mock-up, whether it is in a laboratory or on site or on building. Within the 2813 standard, actually give you quite a few columns, and they have a laboratory system, a laboratory testing column, a field mock-up testing column, an in situ field testing column as well, and then they separate those into their recommendations for enhanced and fundamental testing. And then within that, they have they make it pretty easy. It's probably hard to see on the screen, but I highlighted where they have a little check mark. Those are the mandatory tests within this standard, and then the others have an O in front for optional. And so what we'd like to do now is go through those that were checked as mandatory under the laboratory testing. Why would others be optional? One of the biggest reasons that something would be an optional test is that it doesn't apply to your building. So there's tests about brick veneer systems. If you don't have brick veneer on your building, then it wouldn't apply. There are also levels of testing. How aggressive do you want to be with the testing of the mock-up? So those are the two reasons that testing would be optional. That's up to the enclosure commissioning agent to determine what is appropriate for the project. So within the laboratory testing, we've got a rain screen test, water, air, and structural that are listed as mandatory. If you've seen or heard about laboratory testing, this is kind of the iconic scene. The big fan comes out. This is used in dynamic testing, where the water is moved to and through the test subject, in contrast to static testing that wouldn't be using this fan. So certainly we've had some fun with this here. It's a really productive tool when we use it for that. AMA 508 is a test specification. So there's a little bit of a difference. ASTMs we're all very familiar with, their procedures, sometimes their guides. In our case today, these are all test procedures that we go through, but the AMA 508 is a test specification. And so it will provide a series of test procedures within it, often referencing ASTMs. In this case, the AMA 508 is a rain screen system or a test for rain screen systems. And it will simulate wind-driven rain by creating the wind and driving the rain. Really, this is the probably the most iconic laboratory test. Part of that is simply it's difficult to perform in the field. We'll talk a little bit more about that later. Some other comments on the rain screen cladding. The concept here is that the water is being forced towards any openings or voids that might exist in the rain screen system or the system behind it, the backup wall behind it. This one gave us sound. The difference between the dynamic test and the AMA 508 and this test, the ASTM E331, is that this is a static test, the E331. So rather than blowing the water towards any issues, rather than pushing the water into the component, into the assembly, the entire mock-up is encapsulated in a chamber, and negative pressure is applied at the interior side so that water is pulled in a static test. So one of the great advantages of being at a testing laboratory is that the mock-up structure is provided, you build your mock-up, and the testing laboratory will enclose all sides of it and really create a building type of a condition. On the interior side, on the other side of this wall, there's room for people to stand and observe the testing, and you've created a situation where you have really a section of your building and you're able to put it through the worst case scenario weather events that your building is rated for. So this is static testing. What to expect at a testing laboratory is you're given the space to build and a schedule to build it on. And then once complete, the contractors will leave for a period of time while the testing laboratory encloses it, and there'd be a scheduled testing date to perform all of the testing on the project. The water side of this really stays consistent. It's a calibrated spray rack. It provides 5 gallons per square foot per hour, and that's really every spray rack for the tests that we'll talk about. 5 gallons per square foot per hour is the most rainfall ever recorded in a single hour in the continental United States. So the goal is not to blast your way in with water. It's really a glorified misting system. What the purpose of the spray rack is to make sure that the entire surface is covered with water, so that when there's a void, either the dynamic or the static pressure from the interior side will have the water there to pull it in. So water is on the surface where it needs to be pulled in. You're not really going to get a different result if you were to turn this water up, because the results are going to be driven by the pressure that's applied. The accredited portion of a testing laboratory and a field testing agency has a large factor to do with that they self-calibrate their spray racks. And so there's an apparatus, and when they come and do the inspection every couple of years, one of the things they're making sure is that the equipment that's at the laboratory and used in the field is calibrated and meeting the guidelines. So with all of these tests, this is what happens on the other side. There's room for plenty of folks, but really we're looking for failure. We're looking for water at the interior side. So at this point, this is not the point to start talking about what the pass-fail criteria is. It's really important that that is established well before the mock-up is built, that test protocol is defined, and then that those pass-fail criteria are broken out and shared with everyone involved in the team. It's so much easier to talk about this in advance rather than once things start to go wrong or even perceived as going wrong. An explanation sounds a lot more like an excuse when it comes after the fact. Interestingly, AMA 501.1, which is the component of that dynamic test for rain screens, actually allows a 1/2 ounce of moisture. And in the test standard, they have a picture and a tape measure showing you what a 1/2 ounce looks like, really trying to clarify the ambiguity there. And yet other tests allow no leakage. So you can see how that could be confusing. It's even confusing the concept that there would be allowable leakage on some of these tests, but it really speaks to the extreme nature that they're put under. Discussing it beforehand is really the only way to mitigate the issues that come out of that. Moving on to air leakage testing in the laboratory, ASTM 283. This is kind of a nice one because the field version of this is E783, so a little bit easier to keep those two straight. This is a test to identify the air leakage, to quantify the air leakage through a component. The reading comes in a CFM per square foot. And it's of course going to be different for each of the systems that are part of your mock-up. The curtain wall will have a different rating than the storefront likely, than the air barrier. And transitions are going to be expected to maintain those standards as well. But identifying what your target reading is and what your test subject is. Are you testing the entire mock-up wall and the sum of all components, and what should that be? It could be the rating that you need for that the mechanical design was based on. It could be a sum of all the parts based on square footage. Again, that's up to the commissioning agent to define in advance and provide to the testing lab. They'll test the area that you ask. They'll give you the result that you ask for, but defining what is tested is really going to come from that enclosure commissioning agent. Some of the things that can be, cause an air leakage test to fail would be poor transitions between products that aren't providing an airtight transition. A lot of times metal flashings can foul that up. Undersized gaskets even discovered in the window system. It is rare that a major air leakage issue wouldn't also be a water leakage issue. But that would be determined just after this, because typically the sequence would be to perform your air leakage testing and then your water leakage testing. So the way that's done in a lab is very similar to the field. The test subject would be covered with plastic to create a control, because the chamber around it is going to have some air leakage. You're measuring that air leakage as you put it under vacuum through a flow meter. And then once that baseline leakage, extraneous leakage is established, you'd remove the plastic, wait a period of time, and then get a reading. And whatever the delta, whatever that bump up is between those two readings is your air leakage rate. And then of course it needs to be run through a formula to determine the rate per square foot. And then provided to determine pass fail. We'll talk a little bit about how we investigate a failure when we get to the field testing. And the last laboratory test is the structural component, most commonly done just for curtain walls and storefront systems. Also done on the residential component, but putting it under structural loads, and then after those loads that would measure deflection, and after it's placed under deflection, really it's placed under a negative and a positive pressure, and those are measured as he's demonstrating here, captured and determined in a pass-fail criteria. Now, a lot of times at this point, if you have a curtain wall system on your project, this has already been done, and there's not value to testing this again on an assembly that's already been tested. But if you have a new product on your project, This is certainly of a high value, and if you're looking at it more of a sum of all parts, this is also could be valuable. Timely testing. So we are going to pause here, Joyce. If you have any questions that have come in, or we can keep on going.
One quick question. How often do you do AMA 501.1 hurricane wind-driven dynamic testing in the Western region?
You know, I would say the majority of mock-ups that come into the laboratory do have that testing performed. I think it's the opportunity to do that that drives that. It's here, the equipment is here, and it really has a more logical feel for vindicating and proving the performance of the building, because the condition is so much more lifelike. So we see that really the majority of the time. Certainly if it's a product being tested, it's standard within the curtain wall and storefront testing criteria. So quite often.
And then he followed up with, what about doing it in the field as
Okay,
opposed to in the lab?
Yep, good time to talk about it. There's obvious safety concerns with doing it in the field. There's logistical concerns of you know, lifting it in the air a lot of times. There's logistical concerns with the spray rack and having that secured and located appropriately. So there are alternatives to that. In fact, in the laboratory test standard, it lists ASTM E1105, we'll look at shortly, as the field testing option. When I would say that it's appropriate to go through the extra effort in the field would be in a rain screen application. So the rain screen is going to bear the brunt of the wind and the rain, and then behind it is our watertight air and weather barrier. And so if you had just the spray rack trickling onto the rain screen, there would be no force causing it to jump that gap and get to the interior side. Putting this side under vacuum wouldn't have any effect on the water hitting the rain screen. But when you're putting it under a dynamic test and blowing it, it has an opportunity to get through those joints, get back to the area where it might cause a leak. So it would be one of the only realistic ways with the entire rain screen in place to test that. There is another option too. If you coordinate and it works for your system, you could leave the rain screen cladding off and test at a pressure appropriate to that air barrier behind it, and use a standard infield chamber test, a static test, instead of the wind-driven component.
And I think you're going to answer this next question in your next section. Can a negatively pressurized test chamber be used for ASTM E1105 in lieu of the large blower fan for better pressure control and wind-driven rain testing?
Yes, absolutely. In fact, to me, it's the preferred method because of the ease of practice, with that exception of a rain screen system needing to evaluate what the best test would be for that. I'm a big fan of having at least a portion of those tested without the rain screen cladding in place and testing the air barrier below it, but you have to be careful that you aren't pulling you know, the cladding off of a metal panel rain screen configuration rated to 10 or 15 PSF and then putting the air barrier only that's behind it at that same pressure, because that's not how the system was designed. You can't pull off the cladding and test at the higher pressure. So it takes experience and discussion to determine what would be exactly right and appropriate for the project. And again, you can see if you didn't talk that through and get buy-in from all parties, if there was a failure, certainly someone would cry foul. They may even be right, but it is much harder to deal with once water's been seen coming through a wall.
One more question. Do you ever get asked to do lab or mock-up type tests like ASTM E330 or AMA 1503 in the field on the building?
We do get asked to do those. We don't usually end up doing those. Usually understanding better what it is they're looking for and and the motivation for the testing, there are other options that are available. And really, even within some of those test standards, they list what the field version of that test standard or other options for testing in the field.
Carry on.
Great. I think we're doing all right on pace. Pick it up here a little bit. So timely testing, really on the mock-up. We want to talk about what's different from a mock-up to a laboratory. But we want to test the building like we test the mock-up, and we want to test the mock-up like we're going to test the building. They've all got the same goal, mock-up and field testing, to confirm that the installed system meets the OPR and the construction documents. Most projects really don't go to a lab. Part of that's just location of the laboratories. It's timing. Did you get it planned enough in advance that you can do that? Is it available? Some of the travel costs may be an issue. So you're doing an on-site mock-up. There's a few exceptions where there's a laboratory mock-up and an on-site mock-up, but that's definitely the exception rather than the rule. So how's an on-site mock-up different than a laboratory? The available testing is different. Certainly it's going to cost more to recreate all of that laboratory testing. So generally the mock-up logically is going to follow more of a field testing protocol than trying to recreate a laboratory setting. You'll have to design the structure, and you'll need to design a structure with testing in mind. So a lot of times we get there and we see these angled pieces of tube steel to support a wall that go right through the window and just really complicate the ability to test. Maybe they want the entire wall assembly tested, but they've built so many substructure tie-ins that it can't be achieved. So getting a testing agency or an experienced commissioning agent that understands the testing setup, even in the structural design of the mock-up, is very helpful. The mock-up testing, the in-situ mock-up testing is really going to look like field testing. There'll be chambers built that are usually wood chambers with plastic that give you a little bit of a gap rather than the several feet to stand inside. When you're at a mock-up facility, you have the thickness of the frame, and that's the area that gets put under pressure. But it's see-through. You're able, we'll take a look at that here shortly. A lot of times though, due to size restraints or the equipment of the testing agency, you're testing more individual components than the entire wall assembly. It's not impossible, it's just not nearly as common. The mandatory tests listed for the in-situ field mock-up, or sorry, the field mock-up testing are really similar to what we've seen before with air, water, but there are a couple of added items. And here I've just kind of highlighted those that are mandatory. It is a good portion it's a larger number when you get into the field mock-up. So this is a kind of good eyes on of a chamber going up on an interior side. The plastic gives the visibility, and then it has to be sealed at the edges to create that airtight chamber to apply pressure. Where the extent of the chamber, is it going past the sealant joint? Is it going down to the base of the wall? All of that is defined in the scope and given to the testing agency, depending on what it is that is intended to be tested. It's really great when testing is defined to show that on an elevation view, show the extents of the chamber in advance. Sorry, I skipped a little bit. So the last test was ASTM E783. That's the field version of the air leakage test. The chamber's placed, the plastic on the outside just the same way. We measure for extraneous air leakage and then remove the plastic again to get the delta between the two and the air leakage for the test area. The E1105 is a very logical test to do right after that. It's the water test under uniform pressure, and it's going to use the same chamber It'll likely be at a different test pressure. And then the spray racks moved into place from the exterior, the spray rack providing water at the same rate as in the laboratory, and the test run for the duration required for the project. So test day, scheduling the test days really key to almost as much, almost as important as getting the test protocol right, making sure that it's scheduled and starts on time, that the standards have been distributed in advance, and the pass-fail criteria has been distributed in advance, and making sure the right people are invited. There's a lot of stakeholders on any project. There are people that have responsibilities to witness the testing, perform the testing, and there are people that should just be there should something go wrong with the testing. Describing to people what happened, showing them stills is not as valuable or as constructive as making sure everyone is there. And starting the day having a plan for what you will do in case of a failure. Will you investigate it that day? Will you come back to it? Will there be additional testing required? If you're able to fix it that day, is that allowed, and will we fix it and retest? So defining those in advance really helps it be successful. This is where an accredited testing agency can really become helpful as well. They'll have experience, they have training protocols that are required in order to maintain that accreditation. They have all of the up-to-date testing information. It's interesting, for decades, unless you were a laboratory, you couldn't achieve the field of testing. You couldn't be considered an AMA accredited testing agency, and there was no field testing only, even though there are quite a few field testing only agencies that don't have a laboratory that did great work. Until recently, there wasn't a path for that. So now, of course, as one would do when you've achieved an accreditation or a degree, while you felt complete without it before, after you've put through all that, put in all that work, you would expect that others achieve that, and you certainly see the value to it. There is real value to the field testing accreditation because there is an in-person inspection of your processes, your criteria, your calibration of your equipment. And I think we're seeing it trend more that way as AMA's made that more available to those companies that do only field testing. And it looks very much like the laboratory does. All eyes on the perimeter, looking for water penetration of any kind on this test. And it's kind of like a no-hitter in baseball, where you don't ask how much time is left, and you don't ever say anything like it's doing good so far. It's at least a 15-minute straight test, and the code is to just stay quiet and hopeful, and don't ever say 30 seconds left. Another great test for water leakage testing is AMA 501.2. This is very different than the calibrated spray rack. There's no pressure applied at either side. This nozzle, the gold nozzle that you can see there, brass nozzle, it's actually an oil furnace nozzle. Now, growing up in California, living in Arizona, I've never seen an oil furnace. But I understand that each furnace is going to have a specific nozzle that delivers the oil in a particular profile, and that's really the concept here. They grabbed a particular, it's a Monarch B25 nozzle that provides at 30 to 35 psi, provides water at a specific rate and a specific angle, and the test standard has us hold it 12 inches away. So that allows us to have a reproducible test standard all around the country. Whoever uses this is going to apply it, should be applying it in the same way. It's because there's no pressure, this test is different in that it is trying to force its way in, just brute force, a lot of water, a lot of pressure, many more times the amount of water than a calibrated spray rack. A calibrated spray rack is 5 gallons per square foot per hour, so that's a 5-gallon bucket filled up in an hour. At each square foot, this will fill a 5-gallon bucket up in about 2 minutes. So it's forcing its way in. It's a quality assurance method that's much lower cost, much faster than the E1105 chamber testing. So we like seeing it used in conjunction to allow more windows and more conditions to be tested on a building without a massive expense tied to it. Usually it's a combo of the two tests on any building is the plan. It's also a great quality assurance and investigative tool. So should you fail a chamber test and you're not able to locate the source, you could switch to a hose test and follow some of those protocols to pinpoint where the leak is. One thing that's often forgotten is that this is not for an operable window. You can imagine putting this on an operable window of a home, and that portion, it would just force its way right past it. This does not simulate rain. It says it right in the standard. Because of the force and the quantity of water, it's just something that the industry has agreed that if you fail this test, you'll probably also fail a chamber test. So tremendous value, but really you can't interpret that it would fail a wind rating or a certain rainstorm. Another one of those mandatory tests for the mock-up, kind of interestingly excluded from their recommended mandatory testing on the building, is this air barrier adhesion test. It's a pull-off test for coatings on the wall, but in our application for the building enclosure, we'd be using it for air barriers. So discs are glued to the air barrier, and we're checking to see the performance, the adhesion characteristics of that air barrier product to the substrate. Ideally, we're testing each product on each substrate. And what I mean there by each product is not within an air barrier system like a fluid applied. There's often also a self-adhered membrane. So it's a different product that's going to be placed against to and expected to adhere to a substrate. And then here we have two substrates, a concrete column with a coating on it and existing brick. They would be tested separately because it is a different condition. One of the common misunderstandings of this test is that each test is 3 discs placed on the wall. A lot of times we'll feel like it's a misunderstanding when someone is specified to do 3 tests of the same substrate on a mock-up, which would really be 9 discs. So we saw that one went to a really high, went quite high. What it will do is it'll progress, and then you'll see the moment when it drops when adhesion has failed. And at that point, we're looking to see where did the adhesion fail. Was it the disc that the adhesive failure, the disc came off, but the adhesive is still on the wall. In this case, the disc and the adhesive came off and the air barrier, and we have the substrate exposed. So recording what portion fails is part of that test. And then knowing in advance what your expected requirement is, so you can determine on the spot if it's a pass fail and start to investigate if there are any issues. It's going to be much higher over a concrete substrate, the expected adhesion rating, than it would be over a fiberglass face sheathing. Let's see, an interesting thing to consider is that fiberglass facing is typically rated for about 15 or 16 PSI. If I've been saying PSF, I meant PSI. Where the fiberglass facing will actually pull off the gypsum core at a much lower force than the air barrier is expected to adhere to the fiberglass facing. So a lot of times you'll have that test fail before it achieves the air barriers rating because the gypsum behind it simply can't achieve that. So understanding all of the components and the expectation in advance is really important there, or you may feel like you've failed when the substrate behind it wasn't able to achieve it. We really recommend this on existing construction. Air barriers have funny language. The manufacturers will write things like prime the substrate if required, and then an installer reads that and thinks, well, I don't have to prime it, it's not required. And then if there is an adhesion failure, the manufacturer will say, well, it was obviously required because it failed the test. So you can see the value in getting this knocked out on a mock-up. The trouble is you're not always going to have those existing conditions on the mock-up if you're tying into an existing building. So logically, this would be well done on the building, but you can do it on the building as a mock-up. That's what happened here. They went and just applied a little bit of air barrier to this condition in advance to make sure it would perform as expected. We put all of these systems together, and then we put sealant around the edges and hope that that holds up. So one of the recommended mandatory tests is ASTM C1193, but within that is the C1521 standard that contains a hand pull tab method. So this is a test that's often done by manufacturers. They'll require quite a bit of it to provide their warranty. So a good installer will get their manufacturer's rep out to do these tests, document them, provide reports, and keep that warranty. But as part of the commissioning process, these can really be done by anyone. There's a series of steps. It would be first to identify how many tests, what substrates are being tested. And the ASTM provides the pass-fail criteria here. And so you cut yourself a small tab to grab and pull on, and you pull to a certain length. And then once that's complete, you're looking to see that the sealant has torn apart. It's failed cohesively. So there's still sealant left on your substrate as the sealant pulls out. This was actually a pretty clean tear. Sometimes it will tear just down the middle, more like a zipper. Afterwards, you can evaluate other components of that sealant joint too, and make sure that the profile of the joint is correct, that there's adequate adhesion on both sides, surface area for adhesion, that there's adequate thickness in the center of the joint, that the backer rod's been installed properly to get the profile correct. And again, these are really important for that 20, 25, even 30-year warranty that we're expecting to make sure that this testing gets done. On to the in situ field testing. This is really going to be similar to what's done on the mock-up. It's of course very logical that you wouldn't add increased or more rigorous testing once you made it to the building. It's like just changing the rules of the game to make it more difficult. We wouldn't want to do that. So test specifications really get critical here in making sure that there's a good plan in place that will give us a good test and a good result. And to us, a good result is understanding how to investigate that result, what it means, everyone in agreement of whether it was a pass-fail, and being able to move on to the next test in the testing plan. When we're understood in advance, the results are actionable and resolvable. It's so difficult to have a project where no one knows what's going to be done in case of a failure, because everyone's opinion on what additional testing is appropriate to resolve that, they will all be different, and they're all motivated by different factors, and that really needs to be dialed in advance. Joyce, did we want to pause here or push through to the end?
We're about out of time, Brian, so push through.
Okay, great. 2 tests are added to this standard, the roofing and the waterproofing. All of the other tests remain the same from what we've seen on the mock-up. There is some qualitative testing added for the air barrier. This is a bubble gun method where it will tell us and show us just where the leaks are occurring. You may have passed a quantitative test and then still have some failures here in the qualitative test. So defining that quantitative expectation is key. Another test method within the ASTM E1186 is the smoke tracers. This is also a great investigative tool for air or water leakage testing that has failed. Of course, while it's under pressure on the interior, the smoke will chase to just the right location. And you can do it on a much larger scale as well. This is another pretty dramatic test that can occur in the field, and especially when it starts coming through and billowing clouds of smoke. Roof moisture testing, what they recommend is thermal imaging. Of course, thermal imaging is not an X-ray. You don't get any depth of the scan. It's just a temperature difference. So this can cause some issues and some misinterpretations. It's a good test when administered by someone with good experience in roofing and infrared. Another option here that can be selected would be a roof moisture scan. This is a non-destructive test that's comparative analysis and sends a current through the roof system and will tell you when, will show the technician when the electrical capacity is increased, which often indicates water. But an understanding of the equipment and the roofing system is really key in executing this. The last standard is the flood testing of horizontal waterproofing. The trouble with flood testing is it won't identify pinholes. It'll just find major leaks, which is great, but it doesn't address really the durability aspect of the testing that we're looking for, because the pinholes cause failure over time. Because of that, there's some other options available. Electronic leak detection is very common, but there are not ASTM standards for each of the methods that are used. So we don't see it here in this test standard, but very common for waterproofers and consultants to specify this type of testing because it will actually pinpoint any void or damage in the membrane. Just in closing, it's really important to understand the test standard just so we understand what we're really putting the mock-up through. I think most reactions to mock-up failures are overreactions when we consider the effort and the successes that went into getting to that point and the rigorous testing that they're put under. The value to that is when you pass these tests, it really does mean something. It'll provide you confidence when the wind and the rain comes, and really allow you to, rather than feel stress, feel pride in the process that's occurred. Thanks for your time.
Brian, I think we got a couple minutes. Cut me off if you need to, Sherry. How does building envelope commissioning apply to modular buildings that are constructed off-site?
Modular buildings constructed off-site, I do not have experience with. What we're looking at right now is a modular building where the walls were panelized. There's actually 3 panels here. Each window is a panel. So the panel's constructed off-site and then shipped to the project. In this case, it was tested to verify that construction and also the transition details.
We've got a lot of long questions. Here's a short one. What types of problems do you have with adhesion testing?
Usually it's priming. It's self-adhered membranes going on a substrate that really do need primer. That you know, a lot of times they've made a phone call to the manufacturer's rep and been told that they'll be fine or they should be fine. And some adhesion testing done early would have helped with some of those issues. When they do fail, it's most often either the substrate was dirty or the substrate should have been primed for that particular substrate and product application.
All right, one more till she kicks me off. Do you ever get asked to go to witness testing at a manufacturer's site and product?
Yes, and that's kind of a way around some of the cost of a testing laboratory. If you bring a representative from an accredited testing agency and they witness the test and they're able to make sure that it's done appropriately, then they can provide a report that's actually from an accredited testing agency. That's most common with manufacturers of residential windows, because they'll have their own testing facility there, and they just have you come and visit that, witness that. On new construction projects, we'll see it quite a bit if they've bought it out, where they gave all the testing, they put all the testing in the curtain wall installer's scope, and he's out there trying his best to test it. Then a lot of times they'll bring in a testing agency to make sure that that's done correctly.
All right, we've got one long question, and we're going to do that offline. We'll get an answer to you offline, Ken. Thank you very much, Brian. Sherry?
Thanks, everyone.
Yes, thank you, Brian and Joyce. We really appreciate your time and expertise. And yes, if there are any questions that are still coming in, we'll send it over to you, Brian, if you're fine answering it offline, and then I will send it off to everyone as the follow-up to this Tech Talk. So you will get any questions that didn't get addressed. If you're good with that, Brian, we'll send that over to you after the Tech Talk.
Great, thank you.
Yes, and thank you again. And just a quick reminder to everyone that the fall webinar series is underway, with our next webinar scheduled for October 5th on commissioning for safety and security of buildings. On behalf of the BCA, we'd like to thank everyone for your participation in today's Tech Talk, and have a great day.